All right. Hello, everybody. Welcome back to Reimagine 2020. We have another great, exciting workshop for you today. We have Biconomy coming at you with a presentation. Sachin, the CTO, will go ahead and break this down. You can find this under their workshop, under the in the website, under the Biconomy workshops tab. So if you miss anything, feel free to log in there. Sachin, I'll go ahead and kick it over to you. Appreciate you taking your time out today to do this workshop, and let's have some fun. Thank you.
Cool. Thank you, Adam, for the intro. And hey, everybody. Myself, Sachin Tomar. I'm the CTO here at Biconomy. And in today's workshop, we'll be talking about how we can, build these Dapps on these public blockchains, and how we can actually make the Dapp experience, superlative. We'll go through some of the components of the dapps that we can use to make the experience really good, so that the end users can actually use the applications that are being built on the blockchain. So right now, I mean, the experience is not really good if you see the dapps which are being built. So let's go ahead and see how we can make the Dapp experience very superlative and very simple to use. So let me get started with a very simple question. What exactly is a Dapp? When we come around the term Dapp is actually a decentralized application, that consider them as an application building on the decentralized protocol, which we call blockchain. So if you see the diagram, you can clearly see the difference between a normal application that we are used to today, be it let's say Facebook or Twitter. These all are centralized application, and on the right side you can see dapps. So if you see the components that are being used in both are pretty much different. Let me go ahead with the centralized app section first. You are familiar with this. You have a front end, you have a back end running on your own servers, and then you have some databases, Mongo, MySQL, Oracle, some centralized databases where your data is stored. And there are some disadvantages of centralized app. The biggest one is a single point of failure. The whole power lies with the owner of the application. I mean, if today the CEO of Twitter wants to shut down Twitter, he can totally do that, and all your data will be gone. It will be just gone. You will not be able to access it. But on the other side, if we talk about the dapps that are being built on the blockchain, the main advantage of using dapps is no one actually control that application. It's actually runs on a distributed network of nodes, which we call blockchain. So the top layer, the front end layer, is pretty similar to the centralized application. You have a front end where end user can go and access your application. Now when it comes to the back end, the blockchain is a blockchain in itself act as a data store. So it's a decentralized data store, so no one actually controls that data, and it's always available because of the distributed nature of that. And if you see which part replaces the backend component of the centralized application. So the backend is replaced by these smart contracts that we build on the blockchain. So smart contracts are nothing but just a piece of code written in some programming language, and that is being deployed on this blockchain. So it's the comparison is pretty clear, and the advantage is also pretty clear. On the blockchain, there's no single point of failure. You own your data, and it's secured by the cryptography. So we'll see how we can write these smart contracts, and how we can actually make these dapps easy to use for the end user. So yeah, let's go ahead. So if you see the dapp components that are needed to make a dapp right now, so you need a node is actually needed to get connected to the blockchain. So there are multiple node service providers that are running right now. Let's say Infura is there, QuickNode is also there, and yeah, I mean these are few players that are providing these node services. You need servers, to host your front end code, not the back end, but the front end. You can have your own servers on these cloud platform like Amazon, the Google, the DigitalOcean. But you can also go for the decentralized storage that's called IPFS. You have both the options. So we got the node covered, we got the servers. Now in centralized application, you see when you log in to the Twitter, you provide your email, you provide your password, and that is being stored on the Twitter database. But here in the Web3 world, in a DApp, your login credential lies with your with yourself only. I mean, no one keeps your login credential. You own your own account. No one can control your account, and that's what a wallet is. Wallet is actually a component that manages your account. So just we have email and password in centralized apps. We have public and private key in decentralized applications. So consider public key as your user ID. Using your public key, everyone can identify your account on the blockchain, and consider private key as your password to get access to that account. And you need to make sure that you safeguard that private key by yourself. And this is actually not a very good experience to end user. He have to take care of the private key. But we'll see in the coming slides that these wallets are coming out, which are making this process of managing your account non-custodial also, and at the same time very easy for you to manage. And there are some optional components when you're building a dApp. Let's say if you want to add fiat on ramp, because fiat on ramp is actually making the experience also easier for the end user. So when you are using an application, you need these cryptocurrency tokens to get to use these applications. And to get those cryptocurrencies is also a very, very tedious process right now. You have to go to an exchange, you have to do the KYCs, you have to buy those cryptocurrencies, and then you again have to transfer that to your wallet. But fiat on ramp solutions are just a way to buy these cryptocurrencies from the fiat currency very easily, maybe using your credit card, using your bank account. So that's also a good a component that actually ease the usage of these dApps. And you can always use these data APIs and analytics to see how your dApp usage is how your dApp is being used by the end users, their behavior, and then you can take some actions based on that. So all these components which I just mentioned are already partially solved. There are companies that provide solution for these components. But if you see the unsolved components, there is a transaction management and the relay infrastructure. So I'll talk about what relay infrastructure is, what a transaction management is. So when you see the transaction management, the blockchain transaction in itself is not a very simple to understand. But consider it like a piece of data going to the blockchain, and you just sign that piece of data with your private key, which you have in these wallets. So when you sign the data, you are kind of providing you are cryptographically securing that data, and so that anyone on the network can prove that you actually sent this data to the blockchain and no one else that has sent this data. So transaction, and when we see the blockchain transaction, there are multiple challenges for that when it comes to the scalability of the transaction. So if you see, if you are sending multiple transactions from a single account, there is this counter being managed by the blockchain that we call nonce, and it keeps on incrementing. So you need to make sure that let's say you have sent 4 transactions from your account. Now you want to send the 5th transaction. So in that 5th transaction, that none's value should be 5, just one number greater than the previous one. So all these small details are there when you do a blockchain transaction that should not be should not be the end user or the developer should not be concerned about these when building a dApp. And there is this relay infrastructure. So what relay infrastructure is, it just takes your blockchain transaction and just relay it to the blockchain there, and hence you don't have to pay the transaction fee for doing that transaction on the blockchain. So as I mentioned, blockchain transaction is not very simple right now. You also have to pay for each blockchain transaction that you send to the blockchain. So that that also is not a very good user experience. If you tomorrow you are told that for every tweet you do on the Twitter you have to pay, I mean, I don't think most of the people would be willing to pay for every tweets they do. But in the blockchain, in the Web3 world, that's the thing which comes with the decentralization of the network. You have to make sure that the blockchain is protected against these, let's say, DDoS attacks, denial of services attacks. So you need to make sure that whoever is doing the transaction is actually paying for that transaction. So if he tried to do, let's say, some attack on the network by sending multiple transactions, so it should not be feasible for him to do that. That's why there is this transaction fee associated with every transaction you do on the blockchain. But doing paying the transaction fee is in itself is not a very good user experience. So what relay infrastructure does is it abstract away these complexities of doing the blockchain transaction, and it just make it easy for you to do the blockchain transaction. You just send the information to relay infrastructure, and it will take care of the transaction transaction gas fees, the counter management of each transactions, and the transaction ordering. So all of this will be handled by the relay infrastructure. So we'll talk about it, how we can add this relay infrastructure and transaction management and these wallet services, which makes it very easy for anyone to use a Web3 application today. So talking about the wallets, right now these three, I could find like these 3 wallets that really abstract away all the technicalities of the blockchain, and provide a very very similar interface to the user, which they are already used to. Like if we talk about the Taurus, it's a Web3 wallet that is actually using the Google account authentication to create your blockchain account. So when I say blockchain account, it means your public and private key pair. So you don't need to know like what's behind the scenes, like which public key and private key are being generated for your account. You will be just presented a Google account login. I'm sure you all are familiar with Google account login. You can use your existing Google account to create these blockchain identities for yourself. So this is what Taurus is doing. And if we see Fortmatic is also a Web3 wallet that is actually enabling you to create your blockchain accounts using just your phone number and a password or an OTP. So you all are familiar with the phone number and OTP flow. So Fortmatic is doing that. And if we talk about the Portis is also a blockchain wallet that enables you to create blockchain account just using your email ID and a password. So all these wallets are providing a very similar interface to the user, but at the back end they are enabling the blockchain identities for yourself. So you don't have to worry about managing these private keys for yourself and the public address. You just take care of the password flow and the OTP flow, which you are already used to. So these are about the wallets. And when we talk about the meta transaction, so this term you might be hearing for the first time, a meta transaction. So it's nothing different. I have already explained the how a relay infrastructure works. If you see the diagram and see a normal blockchain transaction, so this is what it looks like. This is the user who is doing the transaction. He is interacting with the front end, and at the front end, you can have these wallets, either Taurus, Fortmatic, or Fortis. They will present you a very simple user interface. You will log in with a mobile number or an email or a Google account, and when you do a blockchain transaction, it will directly interact with this blockchain, and eventually the end user will be the one who will paying the transaction fee for that particular transaction. Now, this is the part, which is not enabling the adoption of the blockchain, actually. So remember when I told you have to pay for every tweet. If you have to pay for every tweet, yeah, I mean not many people would do that. So right now, this problem is there in the Web3 space, that for every blockchain transaction, you have to pay the transaction fee. But we have the solution for that also. This is what we call a meta transaction. So this is what a normal transaction looks like. And if you see the below diagram, the meta transaction one, here the flow would be pretty similar. The user will only interact with the front end of the application, and behind the scenes, the application will not directly interact with the blockchain, but eventually, there will be a middleware here, which is called a relayer. This is the relayer infrastructure that can be, and this is off chain. This is not present on the blockchain, but this is again a service that is running off chain. So someone else might be running this service, or this DApp can also set up this service. So the flow looks like this. User interact with the front end. He initiate a transaction just how he was doing in a normal blockchain transaction flow, but actually the transaction will not go to the blockchain. It will go to the relayer, and the transaction parameter, that transaction data, will be signed by the user's private key, which user doesn't need to know about. And all of this is being handled by this front end. So signature are actually important, so that we can cryptographically prove that you are the one actually who is sending this transaction. So the transaction signature goes to this middleware relayer, and it's the responsibility of this middleware to actually send the actual blockchain transaction, and it will be the one who will eventually pay for that transaction. And now it how I mean, what's the incentive for relayer to actually pay for these users transaction? It's actually up to this relayer and these dApps. I mean, they could do uh, any contract between themselves. Okay, you relay this much amount of my transaction, I'll pay you this much, something like that. So I mean, we don't need to go into that right now, but this is what a meta transaction looks like. So for the end user, I mean, using this flow, what is the advantage? The advantage is, for the end user, he does not need to pay for his transaction. He does not need to worry about getting those cryptocurrencies in his wallet and then paying for the transaction. So the experience becomes very very similar to the Web2 experience. He is not paying for his transactions, but he is able to interact with the application that is being built on the blockchain. So this is what a meta transaction do. And I think meta transaction will play the major role in driving the mass adoption of the blockchain, which I'm sure we'll see in the coming months or year. So, talking more about the meta transactions, taking so right now, many applications are being migrated from Web2 to Web3, but we don't want the experience also to migrate from Web2 to Web3. We want the experience to be similar to the Web2 only, but with the advantages of the Web3 space. So, Metatransaction actually plays an important role in providing a Web2 experience in these Web3 applications. And if we, talk more about how, like, what are the different approaches you can, implement in your application to do meta-transactions. So these are the two approaches. One is the proxy contract wallet approach, and the other one is what we call native meta-transaction. We'll, go through each one of them one by one. So let's talk about this approach. You see this diagram over here. Let me explain the components first. So this is the user interface. Consider this. So let's take the analogy of Twitter being built on the blockchain. So let's consider this as a interface of the Twitter built on the blockchain, where you are you want to make a tweet, let's say. And since this is a Web3 application, you would be having a wallet here, to manage your identity, and you don't have any cryptocurrencies here. So if we talk about the Ethereum blockchain, this is the currency of Ethereum blockchain, Ether. So here this is mentioned that this guy does not hold any Ether. So when so this talking more about the proxy contract wallet. I mean, what are proxy contract wallet? So just how these wallets maintain your identity on the client side by generating these public private key pairs. You can actually have an identity on chain also, on the blockchain also, which we call a contract wallets. So these contract, if you see here, these contract wallets are nothing but a piece of code that are deployed on the blockchain, and from the like the client side wallet has a public and private key pair. This only has a public address. It does not have a private key, but you can control that control the all of the interaction that are happening on your contract wallet using your client side wallet. And let's say the Portis account, or the Fortmatic account, or the Taurus account. So you can sign a piece of information, and when you send that transaction to your contract wallet, it will verify your signature. Okay, you are my actual owner, so I can now process this transaction. So if anyone else try to do a transaction on your contract wallet, the code written on the contract wallet will discard that transaction, because the signature would not match. So this is how cryptography comes into the picture to protect your account. So so if we take the proxy contract wallet approach, one thing is that you have to actually deploy that contract wallet on the blockchain. So you need to first need to deploy this contract wallet first, and then if you try to do a let's take the analogy of again the Twitter. Let's say you are trying to do a tweet. What you will do is you will write a tweet. You will sign that tweet with your private key, and you will send that to a off-chain relay infrastructure, which in this case is Biconomy. Biconomy actually is a off-chain relay infrastructure that is running these services. So this is again off-chain. This is being run on some backend servers somewhere. So you send the information to this relay infrastructure. What it will do, it will create an actual blockchain transaction and send that information in that blockchain transaction. And these are some smart contracts on the blockchain, and this is what this is, we can consider that the smart contract managed by the Twitter, let's say, if it was built on blockchain. So the transaction will go here. So now the relay will pay that gas fees for your transaction, and the signature verification will happen over here. And after the signature is verified, the transaction will be relayed to your contract wallet, and then to the smart contract wallet, which in our case, let's say, is the Twitter contract. Now this is the approach, and if we see the pros and cons of this approach, the pros is you don't have to change anything in your smart contracts, not wallet. This is a typo actually. This is just a smart contract, and this is the smart contract which we're talking about. if you have a Twitter smart contract, you do not have to change any piece of code there, and you can go through this transaction flow, and this user will be able to make a tweet, and the ownership of the tweet will still lie with him. And the pros are, like, these are the programmable accounts. You can actually write any piece of logic in that smart contract wallet. I mean, any logic which you want, and this gives the flexibility to these contract wallet accounts. But the cons is, the transaction is actually going from the contract wallet to this step, right? Finally, this. So let's say if you're writing this smart contract on Ethereum, there is this message.sender property, written in the piece of code that actually identifies the owner of the transaction. But in this case, the owner would be this contract wallet. So the cons would be, first, you have to deploy a contract for every user, and this is actually very costly process. If Dapp try to bear that cost of deploying these smart contract wallet on behalf of the user. And the second con would be, the ownership would remain in this contract wallet and not on the client wallet account, which you have generated using email or using your phone number. So these are the pros and cons. And if we let's go ahead and talk about the second approach, using which you can enable these meta transactions. Here, no contract wallet are involved. The transaction flow is very simple. You sign the transaction data, you send to the off-chain relayers. The relayer will actually trigger an actual blockchain transaction, thereby paying the gas fees. And this is let's say the Twitter smart contract. It will send a transaction directly to this, and your transaction will happen. You will be able to post a tweet without paying any transaction fees for that piece of transaction, and like everyone is happy. But the pros is, like, no contract wallet are there. Ownership will remain with your client contract wallet only. But here are the cons. I mean, for this to happen, you need to slightly change your smart contract code by removing the dependencies on this message.sender and the message.value. So these are some technical terms you can you will be able to know once you start writing the smart contracts on Ethereum blockchain. So this extra piece of work you need to do before taking this flow. And if you already have deployed these smart contracts on the blockchain, so you actually cannot change the deployed smart contract code. But nowadays upgradable smart contracts are coming, where you write the piece of code in a way that you can in the future replace that piece of code with some other piece of code, and that is called actually an upgradable smart contract. But if your smart contract is not upgradable, and you have not enabled, you have not done the changes to enable these native meta transaction, then it won't be possible for those contracts to adapt this approach for implementing meta transaction. So these are the cons here. Many ERC20 tokens are there on the Ethereum blockchain that does not support this native meta transaction. So for them, the proxy wallet approach is the only way to implement the meta transactions. So these were the major two approaches for implementing the meta transaction. Now, when we see the use cases, where we can actually implement. So use cases are pretty broad in this blockchain space. Whether you are building a game on the blockchain, whether you are building a DeFi application, the decentralized finance application on the blockchain, whether you are building some privacy protocols on the blockchain, like if you see on the Ethereum blockchain, the mixers are very popular for providing the privacy for the blockchain the transactions. Or if you talk about the cross-chain interactions also. So any use case you take, meta transaction would definitely be usable in that use case. And like wherever there's a blockchain transaction and you need to abstract away the blockchain technicalities and the difficulties and the abstract away the gas fees, Metatransaction would always be useful in that scenario. So if let me show you a demo, live demo. So this will be interesting, so that you will be able to actually see what's happening, what a meta transaction flow or experience actually looks like. So this is an application which I have built on the blockchain, and that blockchain is XDAI. This application is running on XDAI blockchain. Here you can see a simple quote. This is a quote, and this address is the owner of that quote. And this very simple application, anyone can come on this application, anyone can enter a quote, my first blockchain transaction, let's say. And now if it were a simple blockchain application, you would have to pay for doing this transaction, for changing this code on the blockchain. So, let me try to do this. Let me try to submit it. So here in this application, I'm actually using a MetaMask wallet. So as I mentioned, the port is Fortmatic Taurus wallet. MetaMask is also very, very popular wallet in the blockchain, in the Web3 space. But this wallet is actually a bit technical. So not many users would understand how this works. But I've just used this wallet in this application. So if you see, it is asking my signature, and when I do this transaction, this piece of transaction, this is the data related to my blockchain transaction. Now it's asking me to sign this information using my private key. So signing any piece of information does not cost you anything. It's actually free. So let me sign this transaction, and the transaction actually is sent to the blockchain by the relayer. So let's wait for the confirmation. Cool. So if you see, the transaction is actually confirmed on the blockchain, and you see the code which I have mentioned here, it is now reflected. So if any one of you will open this link, you will see this this code here visible to everyone, and anyone can actually change the transaction. And if I show you my wallet here, this is my wallet, this is my public key, and if you see, I have 0 ether in my account, the cryptocurrency of the Ethereum block, the blockchain. I have like 0 currency in my account, but still I was able to do this transaction on the blockchain, and it was all possible due to Metatransaction. So behind the scenes, if I explain you, the transaction was actually sent to a backend, the off-chain relayers that are being run by Biconomy right now, and that that off-chain relayers actually sent that transaction to the XDAI blockchain, and they eventually paid the transaction fee for my transaction. So for the end user, like it's pretty similar to the Web2 experience. So this was the experience. You get to see if you have enabled this meta transactions in your application. And so if you are actually building an application and wants to enable this meta transaction functionality in your application, so Biconomy actually provides a plug and play solution to the developers, so they can actually use a simple to use SDK and an API or an API to actually implement these meta transactions. So let me talk a bit more about like how you can actually enable this using Biconomy solution. So with Biconomy, all you have to do is register your application on this dashboard which we have, and once you register your application, you just integrate the Biconomy SDK on your client side, and that's it. Like you will be able to integrate meta transaction in your application. And for more information, you can actually go to this link where all the integration steps will be given step by step. So if we see how the documentation looks like, this is the documentation. You can actually get started over here, register your app on the dashboard, integrate the SDK, and then registering a Dapp on the dashboard are being explained here on the Biconomy dashboard section with all the screenshots. And if you see the Biconomy SDK section, very simple integration steps: installing the package, importing the Biconomy, and initializing your Web3 object. And yeah, and doing the all the initialization stuff over here. So you can actually check out this documentation. It's very simple. And we also have some tutorials over here. You can, if you are new, you know, and if you are just figuring out how to build your how to build your first application on the blockchain, you can actually follow these tutorials. These are also step-by-step tutorial for any beginner, to build the application. And then eventually you can, integrate Biconomy also in your application using this tutorial. So, I would recommend you to go through this tutorials and the documentations for integrating Metatransaction in your application. And there are some useful links over here. Biconomy documentation, we have our SDK is open source. You can actually go to the GitHub BCNMY and check out the SDK code and try it, play around with it. You can actually contact us also. We are on the Telegram, we are on the Discord. So whether you are using Biconomy or not using Biconomy, whether you are facing any challenges while building any application, we would be happy to help you guys. We are actually making sure to you know to evolve this Web3 space together. And I would encourage you to try building your first app today, and then try it out, see the experience, see the advantage of using Dapps today as compared to the centralized application. And I'm sure if you're a developer, you will be really fascinated by this blockchain technology. And any difficulties which you face during blockchain, during building this application on blockchain, just reach out to us and we will be happy to help you. And that's it. Thank you. Adam, you there?
Yeah, hello there. That was a great presentation.
Thank you.
Thank you for going through that. I think that was a lot of info, very insightful.
Yeah.
I think our viewers are definitely going to like that. I like the way you broke it down. So that's good for everyone that's going to watch.
Yeah. Thank you.
All right. Well, I think this sums up and concludes this workshop for now. Reimagine 2020 Biconomy. Where can they find you?
So you can actually go to this link docs.biconomy.io, and there is a contact us section over there. You can reach out to us on Telegram. You can reach out via email, on Twitter, on Discord. So you can reach out from there.
Awesome. Appreciate that. Well, I think that concludes here. Again, for all the viewers and audience here, this will be uploaded into the workshops tab, and then you could find Biconomy, and this will be available. All right, folks. Thank you for your time. Sachin, thank you for your time today and presenting this.
Thank you, Adam. Thank you. Goodbye. Take care.
All right. Sorry. I just